Thank you. So good afternoon. Welcome to my second presentation at this conference. So I think by now everybody knows that I am now a part of EDB, like how for years people were approaching me, like reading my yet another startup and asking, so who you are with and where you're from? I like, it does not matter, that's me. So like, one startup later, two startups later, three startups later. So since December 1st, I'm a part of EDB. So this talk, so first of all, I just want to tell everybody up front, that was a substitute talk. It was not the one I prepared to present. So the main talk was yesterday, and this one kind of emerged after 4 cancellations of other presenters. So it's like a little bit underdeveloped, but I think the topic is important. So I just decided that I still want to present it. So if you have been to my many other previous talks through many years, it's not my typical talk because I won't be showing some cool thing which I invented. I will be talking mostly about what we do not have. We as Postgres community, I as one of active members of Postgres community, and like what we can do about it. So basically the theme of this talk is a database from the software engineer's perspective. So as I said, my past 3 jobs were with startups, and what you have in startup, you are one database person, okay, sometimes one of 2 database people, surrounded by software engineers. So yeah, in this lion's den of software engineers. And they do not like working with database people most of the time. They think that like they do not need database people because everybody knows how to write SQL, right? Because SQL is one select operator and nothing else. So they know how to write SQL, and Postgres sucks. Like each time something does not work, it's all Postgres' fault. So for years, when I was doing talks about how to, people like kind of cheer this, yes, the software engineers, application developers are difficult. And we like to say that they are difficult, they do not know how to write good SQL. But recently I kind of like decided to do a deep dive in what exactly they are unhappy about. Because we in the database community and in Postgres community specifically, we are very vocal about what we do not like, what they are doing. And we rarely listen to them, what they want us to do. Even when we're talking, okay, we're customer face, we're doing what customers want, we deliver the features. So who are our customers? Actually, our customers are not the companies who hire us as experts, not DBAs, not the end users, because the end users see our results, our work through the application. So our true customers are application developers. And they have lots of issues with what we are not providing for them. So I developed this talk for Chicago Postgres user group. And again, as I said, it's like kind of have lots of birthmarks from my last place of work. So it is not yet open sourced. It's not in my GitHub, but it will be there shortly. So I will remove all specifics, and it will be totally anonymized and company neutral. So hopefully people will be able to benefit from it. So why I'm talking about this? So partially I already said why I'm talking about this. So because software engineers are our first customers. And that's how people see database. Because our end users do not sit by computer and do not type select statements. They see our results through the application. And because almost nobody talks about it. And even we heard Magnus talk about Postgres 14, so for developers. He means database developers. In most of talks, like for developers, application developers, they're talking about SQL developers. And very few people talk about application developers. Okay, and so I am trying to basically give a new perspective, so nothing what I will be talking about today is new or you never heard of, but kind of like maybe, hopefully, from different angle, for somebody at least. Okay. So why they are unhappy? There's like a short list of like their grievances, and I will go in details about each of the items. So the items are database design tools, database version control, deployment, access management, data branching, and there's like only a few of these, and I won't be covering all of them in this talk. So design tools. So I don't know how about you guys, when I hear application developer says, we need this table. You know, it's like, gosh, you do not need a table. You need to store data. You need a new object. Do not tell me whether it's a table or it's materialized view or a set of table. It's not your business. And then I think, okay, Hetty, so how you want us to present you what we want? It's not table, then what? They want us to draw ER diagram. Actually, no, I don't, because we do not have good tools on making tables from ER diagrams. And what if we want to change something? So what you want to store is like our current design. Like, nope, nothing. We don't know. So that's like one of the reasons for their unhappiness. Version control, oh my gosh. So for start, you know, application developers, they develop applications, develop programs, and programs have source code. So whatever they have, that's what they run. So they store it in GitHub, they create releases, they deploy these releases, okay, application is running. So technically speaking, database does not need a source code. So we have, here is our database, perfectly fine, up and running. It technically has no relationship with how all these tables, materialized views, or stored procedures, how they ended up there. They are there. And lots of companies do not store database code anywhere. It's not even about Postgres. I saw companies who are running SQL Server, Enterprise Edition. Where is your source code? In the database. So how you deploy? Just run SQL, compile, create storage procedure. So that is big disconnect, and software developers are super unhappy about this. And then they're saying, okay, so wonderful. You do not store it, or even if you store it, how you can tell what is the difference between this database and that database? And they're like, no, we cannot compare source code because source code may be different. Like, yes. So the source code may be different and databases might be still the same. So that's like a huge problem. All right. What makes two tables different? Like, for example, like question I had to answer. If the tables have the same data, the same set of columns with the same fields, but the columns are in different order, are they different or the same? And technically speaking, from like relational theory standpoint, if we have named attributes, it should not matter which order they are. Yeah, until we have somewhere select star or insert somewhere, select star from somewhere, and then we have all this different story. But it should not matter. Or like if constraint names are different, because in one place you name them, in the other place you took like a default constraint name. Or the index name is different. So is it the same or different? If you compare source code, they're different. So what are the reliable ways? So that's like other complaint I've often heard, okay? Deployments. Oh my gosh, like how you are doing deployments. Like, I know how I do deployments, you know, but that's artificial, how you can make it automatic. Because what software engineers used to, they have, again, they have their source code, they develop it, so they have the branch, and then, okay, they deploy, they compile this source code, and they are good. So they do not care what it was before. It's new code now, and if we have in GitHub, drop table, create table, that's not what we're deploying. Or if we have create table if not exist, it's also not what we're deploying, because most of the time what we did, which added column, we removed column. We change the type, we edit index. So that all means that we cannot deploy from GitHub. And then how we're doing deployment. So there are multiple ways to do it. One is what I prefer, to request deployment script. But then, okay, you're reviewing these changes in GitHub before commit. So you need to review not only new code, but you also need to review whether deployment script adequately represents what will happen after it is deployed. After deployment, it should look like in the file. So it's all artificial, okay? Okay. Maybe we can generate patches based on what? Again, where is the source of truth? If we generate patches, we are generating them from where? Again, we do not have to store database code. So that's other conversation. How you can tell whether one function is different from the other functions. Well, so function body different, the only thing you can tell, they are different, not the same. And I'm million reasons why they may be different. So all these are other sets of issues. Security. I will talk more about this, but this is super painful topic because you know what? I will be first to admit access control permissions in Postgres are not easy to understand. So when we have something granted directly to user, something granted to the role, something revoked from user, so how I can tell this user, my application underscore user, what permissions do they have? I'm like, what do you mean? I can select from privileges, pgpriv? No. You don't need to select from pgpriv. You need to tell me the list of what objects they can access and what they cannot. Is there easy way? There is no easy way. So there's another sort of grievance, how we compare privileges for different users, how we compare privileges in different environments. And different environments is actually huge, so that's what we'll talk a little bit. So what I will present, and I don't even want to present, it's not about what I did. I did some work to mitigate some of these issues. But the point of this talk is we as community need to make sure we have tools like this readily available. Because at the end of the day, again, software engineers are our customers. If we want them to use Postgres the way we want, if we want them to use new features, because we're developing new features, they're not using it, because they're not doing big joins, they're doing select star from table A, select star from table B. Because they do not know, it's too complicated, million other reasons. And they're database developers are bad software engineers. Yes, we are not software engineers, but we need to walk our half of the way to make Postgres a little bit more development tool, because it's in our interests. That's what will help us to help developers and help the users, etc. So that's first part will be how to compare different schemas in different databases. So we want to compare two environments. We do not want to compare source code because, again, we do not know what from this source code went to development, QA database, staging, production. So the only place where we can tell that's how this database looks like is Postgres catalog. So the important part is if we want to compare databases, we want to compare catalogs. So there was an attempt to do schema compare in the latest PG admin version. So we have some. So if somebody tried, I tried. It does not work as expected. And it works very slow. It doesn't work as expected. So I developed a tool to compare different environments by comparing catalogs. So I will just give an idea. Again, this code is not open source yet. It will be shortly, hopefully, promise. No. Okay, no, seriously. Before the end of the year, okay? It will be open source. So that's kind of again, just give an idea. So I'm doing it using foreign data wrappers. Because, okay, you are sitting here on your computer. You want to compare from your local computer. So from your computer, you can connect to everywhere you are allowed to connect, right? You can maybe connect it only to production. You can connect to staging. You connect to your local. You connect to your local test and development environments. So I create a schema diff, and I create as many Postgres foreign servers as I need to accommodate all environments. Most of the time, the convention in the organization is that environments have the same name and different prefixes. So this can be customized to make sure that we name all the environments accordingly. And then we import foreign schemas, so we import PG catalog and both in the NC catalog and information schema. So in some cases, one is better, in some cases, other is better. And then we compare catalogs, and that actually runs instantaneously. Life is beautiful. It's not like when you try to do schema compare in pgadmin, it's like instantaneous results, okay? So what we can compare, what people want to compare. For example, a list of schemas ownerships, whether they're the same, whether the owner is the same. List of tables in the schemas, how they're different. List of columns in the table, whether columns are the same. You can actually decide whether you want to check whether the column order is the same or you do not. It's like you can easily do it when you query a diff. And list of constraints, same, but the constraints are only differ by the name or they differ like substantially. Some are missing or some are extras. And then I will talk separately about permissions. So again, like big pieces of code. So the idea is you do diff environment A, environment B, union all, diff environment B, environment A. So that's all this thing does. And then we can compare. So here what we are comparing. We compare which schemas are in dev, which schemas are in prod, and whether permissions are the same or different. So here we can say there is like one first schema is all in prod, not on development. Okay. Then this one's back schema is have different ownership on prod and dev, which is probably okay. So I can actually mask the schemas which are all different by the owner, but if we compare prod and stage, we want to know what is the ownership because we want to have ownership the same. So it's like very easy compares. Here we are comparing one particular schema. So we compare whether in schema stats we have whether the list of tables is the same. Like, okay, yeah. So there are extra tables. Well, tables are missing. Then we can compare columns. So here we take two environments, prod and dev. We take all the schema app and we just see all the differences which are there. The list is huge, actually. So something. We can compare columns in the specific table. So here we can see which ones are different, which ones are missing in prod, which is probably fine because we're developing in dev and we have new columns which we want to add. Then we can compare constraints. So again, same story. We can compare constraints by name, and we can compare constraints by what these constraints are. So you can do both ways, and there are like flags which allow to do like all different things with this. So now, because we like compare this, and then we can compare privileges. So privileges is like two-phase compare. So what I'm doing here, I'm comparing the privileges which are defined in Postgres. So in this schema, in this function, I compare what is granted and what is not granted, and again, I compare between different environments. But that's not it, and I will talk more about privileges compare in a little bit. But after we have all these simple functions, and I mean, honestly, it's look a little bit ugly because it's dynamic SQL. I built comparing catalogs, comparing foreign tables, but they are very easy to execute. So we can see all the diffs, and guess what? Now we actually can generate patches because now we know how the databases are different, not like how the source code is different. So I created another set of functions which allow to generate patches, and you can generate either way. So for example, okay, oh, sorry, that's more compare privileges. Yeah, I forgot about this. So here we are comparing privileges on the schema level. Yeah. default privileges on schema. That's another story. Yeah, so now we can generate patches. What we are doing here. So how these two calls are different. First, generate patch makes prod look like dev. So what it means, we developed something in our development environment. Now we want to generate patch to apply it in production. So there'll be one result, right? It will create this alter table. Then if we want to do the other way around, so here we're doing, okay, so now we want to make dev environment look like prod, because, for example, we want to start fresh, and we want to make sure that in development environment, everything looks like production. So then it will generate reverse patch, not add columns, but drop columns. And these functions can do pretty complex things with this. So I distinguish between whether it's like add, drop, alter, make it from null allowed to not null, add default, drop default, change type. So everything can be generated. Pretty much everything on changing tables and changing columns and changing constraints. So here is the other function where I generate new constraints. So again, we can either add constraint, or we can rename constraint, or we can remove constraint. So all kinds of transformations are supported. And here you do not need to guess whether we forgot something or we did not, or whether everything is in the right place, because we actually read catalogs, we compare catalogs, and everything comes from these catalogs. Okay. Now compare all privileges. You know, I had the hardest conversation about this, because, okay, I know what Postgres does with privileges, right? Because it's all in the catalog. We have default privileges on schema. We have several places where the privileges for specific objects are recorded. We have separate place where we actually record which roles are granted for each user. And by the way, how many times you were asked, can I see all roles granted to this user? And you cannot find it in documentation, but if you Google it, you will find like all these selects are coming up because people need it, and people are coming up with them, and then you just need to, okay, how you do this, and SQL comes up, so that's we can generate. So what's important here? Different set of privileges can come from different setup. So for example, you can do this. Grant select on all tables in schema to a new user. And that will be just all tables will have select, okay, all existing tables. On the other hand, you can do like grant select on each table, and it will be recorded in the catalog differently, but result will be the same. The new user will have select privileges for all the tables. Then you can grant select on all tables in schema to the role, and grant this role to the user. Again, for the user, result will be the same, but how it looks in the database will be different. And then that's what people ask. So, hey, Katie, you are saying our permissions sucks. Yes, they are, because you are doing all this like granting everything to individual user and forgetting things in between. Yes, I want to do role-based permissions. Okay, how you can prove to us that you will do the same? Because I know it's the same. No. We need to see the results that these permissions are the same. Like, I cannot tell you because that's what Postgres does. It's not where it's recorded. No. Tell us. So, what Katie is doing with this? So, first of all, I Googled this SQL because the SQL is like repeated. I mean, maybe like people, at least one person who wrote the SQL is here at the conference, but I mean, there are definitely more than one person, more than one people who come with the same SQL. So what the SQL does, it's literally first thing which Googles when you want to see all the set of privileges. It will show you for each user the full chain of granted roles. So if you are granted role, like for example, read on the schema, and read on the schema is like comprised of like grant select on all tables. So all these chains, like 3, 4, like 5, whatever nested levels of roles you can see. But then what you need to do for each of these roles, you need to go to specific privileges for this role and kind of unnest it and parse it and find all the objects, what permissions are. And again, for schemas, for usage privileges, for sequences, for execute, they are like in 20 different places. So I can tell the whole function, like which returns the set, is like 117 lines long, but then I generate full, complete list of privileges. And you know what we do then? We just save it result in environment 1, save result to environment 2. Okay, now are you convinced? Did I prove to you that that's like the same set of permissions after what I do and after what you have? So that is like, gosh, super painful process. And you know what? People have a right to be unhappy. So when I talked at my most recent company, like, okay, guys, so I created for you this thing to compare environments. You know what they ask? Like, are you telling me Postgres does not have it? It's such a natural thing, like, Postgres does not have it. And I mean, honestly, we operate as if we do not know that people develop in different environments that look semi the same. As if nobody had this problem. Everybody, each and single person had this problem, that we do not develop here and then, like, we do not develop on production. We do not we do not stay where our experiments are. Everybody have multiple environments. Why we do not have it? Okay, not as a core Postgres, but something handy, readily available. You can, okay, developers, here is what you can use. I don't know. So I had a hard time answering these questions. So, like as I said, that's like my plan for future work is a little bit like straight, you know, off the assembly line. So I plan to add indices compare, finalize all patches generation, so I do not have page generation for this indices. Then I will do parameterizing. So right now it's like partially parameterized because you can name your environments. And so what I want to do, I want to, okay, here is my company, here is like how my databases are called, and I'm just, you know, plugging it in, and then these functions allow to kind of by default, it's something which is defined on your local, because many people actually access it through like HTTP, so you define external databases on your local ports, and like people do it in all different ways. So there will be liberty to set it up how you want it, how it works for you, and then you can do all this comparing on your local computer, and you can do sanity check before deployment that things actually work. But like as I said, most importantly, I just think that this should be more visible. This problem should be like visualized, verbalized, and that is something which should be readily available. So other issues, again, I did not cover. I just kind of like want to go over because something I want to do or I want somebody to do. So using PG tabs, we do not use them enough, I can tell. It's for many companies, it's not a part of development. You look at Java developers, you look at Ruby developers, they do not do anything without unit tests. We do things without unit tests because we don't have time, because the tools which automatically generate PG tabs, they are, but it's like another separate installation why I do this. Actually, I created a couple of SQL functions to generate PG tabs because I do not want to install another apparatus just for the sake of generating tests. PG tabs for functions, we do not have any standardization. It's super important because we change functions. We want to make sure that they still produce the same results. Designing tools. So one kind of compromise I got at my last work, okay, we can design in types. So that's one thing I want to do. If people can design the objects in terms of, like my talk yesterday, in terms of JSON schema, in terms of complex Postgres types, then we need to give this tool, and we need to give the tool how we can kind of take this and use it and create a database representation. But if we do not want developers to create tables for us, and we do not want, we need to give them other tools. Test data sets, oh my gosh, you know, that's why you cannot actually test functions, because you want to have data sets. And Ruby developers have all these like data factories. Why we don't have data factories? I mean, somebody might have it. So the interesting thing is, I talk to people, oh, you know what, I saw this, or I created it. Like, why we have to go and search? Why we do not have it somewhere close to home? Having data factories is vitally important, because we also, like what we're telling them, yeah, you test it on your local with no data, and how it's going to work in production with lots of data. Okay, let's give the tools to generate test data. So the other thing, again, developers told me, I never thought about it, can we do data branching? I don't even know how to do this, but I think it's like a very important concept. So they want, in GitHub, they want to have different branches with test with one set of data, test with other set of data, and decide like basically what works, what does not work, what want to go. So again, that's incomplete list, but that's what people want. So yeah, and I think that most of these things should be addressed at some point. And yeah, so I've like said it's kind of raw presentation, but that's pretty much it. And thank you for coming. Thank you for listening. And questions, if any.
Thank you so much. In your comparison of the column names, and it looked to me like you were capturing data types, are you also comparing data type size limits?
Everything. I compare everything.
Gorgeous.
Yeah, I just, you know what the thing is, again, there were examples which I submitted presentation on the material of my previous company. I'm not there anymore, so kind of whatever I had. No, I compare everything.
Beautiful.
I compare type, I compare size, I compare defaults, if any, or absence of those. I compare null, not null. So when I generate patches, I have all of this.
I'm so excited to hear that, because I'm at a place where our prod and our development have different sizes on like varchar 256 versus varchar 20, and it hurts things.
So is this implemented as an extension? Sorry, big room. Is this a C extension?
It's not extension. It's
Okay.
functions. They're Postgres functions. No,
Okay.
I am.
PGS,
I'm not a C programmer.
Okay, and what's the name of it so that we can?
It's. I will have it, like as I said. It's.
No, I understand. What's it going to be named so that we can watch?
It will. Okay. So it will be called diff. Yes, diff, and it will be in my GitHub. Gosh, and I don't even have my. In GitHub, I'm Hetty-D because nobody can pronounce my name, neither first nor last. So Hetty-D, and it will be called diff. Yeah. Like yesterday, I was like posting my norm GitHub, and it's like we'll be somewhere around there. Yeah. No, you know, I came with lots of ideas. So that's my third day with ADB, as I told you, and I was talking with people like the week before, and they're like, I have lots of ideas. I want to do this, I want to do that, I have lots of ideas. And I want them to be like more part of Postgres, so yeah.
Yeah, thank you for this topic. For the generation of patch scripts, how do you handle, or do you handle the dependency order?
No, and that is something which we need to address. Thank you. That's actually a very good question. That's why I'm telling you page generation is not complete yet. Because, I mean, how I'm going to do it, so right now, what's going behind the scene, I select one set, I select the other set, so they're sitting in two temporary tables, and then I'm doing like diffs between these temporary tables. And so if, so what I'm doing now, the constraints go separately. So I'm kind of like bypassing this because I first create diffs for the tables, and when I'm done with tables, I apply diffs for constraints. So basically, first everything and then everything, which you are right, it would not work. For example, if we need to drop a foreign key and we need to drop a function. So no, work in progress, but yes, thank you for the question. Mm-hmm. Right? Anything else? Nope. Right.
All right, I
All
think
right.
that's
Thank you. Thanks
thank
so
you.
much.